Right, good evening everybody. Assalamu alaikum. Today I am going to teach you about the parallelograms second theorem at the chapter 1, right, unit number 16. In the previous classes we have given two video clips. Now the rest of the theorems regarding the final properties of a parallelogram, right. Dear students, now you are very clear to this parallelogram which was taught in previous classes. You are very clear in this manner, right? Now the second theorem, according to chapter 1, the diagonals of a parallelogram bisect each other. This is the second theorem. In order to prove the final properties of a parallelogram, right? We have four properties for the parallelogram. The first of three had been proved in the final previous class. Okay, in the second video, you can verify that. Now, in order to prove this geometrical conclusion, we have to do some work. Now, in order to cover up the time, I have drawn this picture earlier. So please draw this parallelogram using pencil and rulers, very clear. Write it down. Now, look at this information at under the data. Before we have to do this work, we have to set up the usual format. First of all, we have to write this data. Okay, ABCD is the parallelogram. Now that is given. Diagonals AC and BD. Diagonals AC and BD, right? Each other intersect each other at the point O, right? These are the given data. Now look at this picture now. Along this each side, this is according to this whole diagram, we have to select, right? What do we need to do here, right? To be proved, first of all, according to this data, the diagonals of a parallelogram bisect each other. That means AO equal to OC, BO equal to OD, right? AO, this length, equal to this length, OC. Similarly, BO is also equal to OD. This is what we are going to do here. Okay, my dear students, now please copy this. Following this instruction, now let's prove this conclusion. First of all, we have to select pair of triangle inside this parallelogram, right? In order to prove this, we have to select a pair of triangle that should be opposite to each other. You should not select this and this. You better to select this one. Then only we can prove easily. Right. First, in triangles AOB and COD, right? In triangles AOB and COD. Now you are very clear in the geometrical conclusion, right? Which were taught in previous grades, okay, previous lessons. Now you see, this is the angle equal to this angle, according to the alternate angle. Right here, this is opposite, vertically opposite angles. This is also another pair of alternate angles. There are three types of angles here, but we need only two angles, right? Then according to the first theorem, we can put the notation this mark in order to make this length of AB and CD equal to each other. We can put this mark. Okay. Now, in order to prove, first of all, we have to select two pair of angles. Right? There are three types of angles. So we need only two. Whatever you can choose. You can choose two of them. Okay. Write one by one. First, I am going to write here AOB. Angle AOB equal to angle COD angle. Okay. What is the reason? The reason is very important. That should be indicated in the bracket. Vertically opposite angle. Vertically opposite angle. You know you are very clear. This is the fundamental axioms and geometrical relations, right? You are very clear in this manner in previous classes. Vertical. When you put this together, vertically opposite angle. That means both are equal to each other. Then the second choice, there are two choices. You can select one of this, right? I am going to take this ABO equal to this one is equal to this angle CDO. What is the reason? Alternate angle. Right? Now we have found two elements inside the triangle. We need another element that should be a side of the triangle. Now that is very obviously clear to you all. AB is equal to CD. AB equal to CD line. The reason is opposite sides of a parallelogram. According to this first theorem, we have done this in the first theorem. Opposite sides of a parallelogram equal. Okay. So finally you can write the conclusion. Therefore, AOB triangle congruent to COD triangle. At the situation of double AAS angle Z. Okay, this is the conclusion there. Now write it down, all of you. Now, you are very clear in this chapter as you learn in the previous lesson. The congruence, the pair in the congruent pair of triangles, we can come to the conclusion rest of the elements are equal to each other. So, in order to find out the things, what we need to do here, AO equal to OC. AO is here, OC here. So, this angle, this triangle and this triangle are congruent. Now I have proved. So according to this, therefore, right? Corresponding elements are equal in a congruent pair of triangles. So according to that, you can write it here. AO equal OC. The reason is, the situation is or reason is corresponding elements of congruent triangles. Right? Similarly, you can write the same BO equal to OD, right? The same region. Now look at this conclusion. Now after this conclusion that we have proven the pair of triangle AOB and COD, we can write the conclusion that AO equal to OC and BO equal to OC because corresponding elements of congruent triangles, right? According to this, that you can come to the decision. Thank you all of you. We'll meet in the next video for the chapter 2, unit number 17. Now we have finished our chapter 1. There were two theorems here. In order to prove the special properties of a parallelogram, right? There were 4 properties, right? 4 properties under the 2 theorems. So we have our 2 theorems. There are 4 other theorems out of 6 theorems. So we will see that in the next chapter. Thank you all of you.